Hey, so this is a slightly different video. This is a recording of the talk that I gave last week at Dutch PHP conference. And yeah, I wanted to share it with all of you as well. I think it's an interesting topic, generics in PHP and, PHP's future in general as well. So definitely give it a watch and share your thoughts in the comments down below. I would really love to hear from you what you think about all of this. I hope you enjoy, and I'll see you soon. So, generics in PHP. It's this topic that many people talk about, and whenever you ask about people's wish list for PHP, generics is right there on top. So today I want to start by giving you a brief introduction about generics because not everyone is familiar with them. But I hope I can convince you about their usefulness pretty quickly. And because as soon as everyone here is up to speed with the basic idea of generics, I want to dive into the question, why don't we have them if they are such a requested feature in PHP? What's going on there? It's actually a pretty interesting topic that goes from static analysis to internal development to questioning kind of the very core of what kind of language PHP is. So that's the plan today. I'm Brent. I'm a developer advocate for PHP at JetBrains. We create PHP Storm. I'm also the host of PHP Annotated, our YouTube channel. Subscribe if you haven't. And I have a blog you might have heard of. It's called Stitcher.io. So let's explain generics. I need to make an assumption, and that is that you don't like bugs in your code. You go to great lengths to prevent them. And you write tests. Maybe you have some automation in place. Maybe a dedicated QA team. Now, another thing you can do to prevent bugs is to use stricter type checks, because the more information you have available to you about data that's flowing throughout your code, the more accurate you can deal with that data. An array is just an array. It could contain anything, but a collection class that only accepts a certain type of object, well, that's a bit safer. There are less edge cases you need to think about because if you have an instance of this post collection, you can be certain there are only posts in it. PHP's type system has checked that for you. On top of that, you get autocompletion and code insights in your IDE simply because it has more information available about your code. Now, PHP's type system is kind of weird. It checks types at runtime. Now, why is that weird? It sounds pretty obvious at first, doesn't it? We're only adding data to our collection when we're running code, right? So naturally, PHP can only check that data when our code is running. Well, in an isolated example, that reasoning makes sense. But what if you add types all throughout your code base? Suddenly, you get a lot more certainty that things will work just by reading your code. We're sure this collection can only contain post objects because it extends array iterator and checks whether a new item actually is an instance of post. We're also sure that when we create this collection, we're only adding post objects because their type has been checked when calling, for example, this function. And we're certain that this is actually a post object because we've created it here while knowing its type. And we're also certain that this post got the right data because all its properties are type checked. Now, all of this to say, the more types you add, the more certainty you get that your code won't break while running. All of that without actually running it. Now, that doesn't mean that your code is bug-free, but it does help quite a lot. And this practice of being able to validate your code without running it, that is incredibly powerful. It has the potential to save quite a lot of time and has the potential to prevent bugs in production code. Now, an important side note to make is that even when you use types, you'll always need some kind of entry point somewhere in your program, a place where you're dealing with raw input data and where the data needs to be cast into something else. If we're talking about HTTP applications, everything is basically a string coming from request data. So the edges of our code will always have to deal with typecasting and validation, error handling. But for the rest of our code, being able to check types really pays off. Now that brings us to static analysis, because doing all of these checks by hand gets difficult pretty fast. Static analyses are tools that read our code without running it and find places where types don't line up. They essentially tell you about places where your code could break if you were to run it. Now, this automation of type checking is when you really start to feel the power of a type system. And PHP has a couple of static analyzers. There's PHP Stan and Psalm. There's also Fan, created by Rasmus. And of course, there are the IDEs like PHP Storm, which also have a dedicated static analyzer. Now, there's an important distinction to make between IDEs like PHP Storm and static analyzer tools like PHP Stan or Psalm. PHP Storm's first goal is to help you write code, so its static analysis happens in real time, while tools like PHP Stan, they scan your code base in bulk and report all errors at once. And these two aren't mutually exclusive. It's easier for PHP Stan to do very in-depth analysis because it doesn't have a real-time constraint, while PHP Storm's strength is to help guide you while writing code. Now, I want to give you a couple of examples of what static analysis can do for you. PHP Storm has autocompletion while typing. It knows this post object has these properties because the post variable has a type. And PHP Stan can detect whether a condition's else block can't be reached because it understands how Boolean expressions work. And what if you have a method that doesn't return anything, but try to call it and store its values in a variable somewhere else? It's perfectly possible that someone else on your team has written this parse method and you don't know exactly what it does. Now, static analyzers will guide you towards the right solution without having to read documentation, for example. And truly, the power of all these tools is that they read your code. They don't run it. They detect errors and make code suggestions solely based on text. And of course, types play a crucial role in understanding that text. But I was going to explain generics, right? The thing about types is they become boring pretty fast. There is some textual overhead to using them. You have to write them. Imagine that we have 10 different kinds of objects that need collections. Will we write 10 different implementations? We could add some more abstractions, but honestly, this is a mess. So this is where generics come in. Instead of writing 10 times the same class with only the types being different, you could write one generic implementation with placeholder types. And then you can pop in the right type when you need it. It's a form of code reuse on the type system level. Now, big disclaimer, this syntax isn't possible in PHP, but it is the syntax that is used in most languages, so I'm using it here to explain the concept as if it was available in PHP. Now, if we were able to do something like this, we would have all the advantages of using a type checker, error detection, autocompletion, but with a lot less boilerplate. And I know that like the collection example is the classic one when explaining generics, but there is really so much more that can be done with them. ORMs that return a specific entity or model class from their query builder is one example. You could introduce a concept of a generic class string, and then you can make functions that resolve an object of that class string from, for example, a dependency container, all while ensuring type safety. And truly, generics are wonderfully versatile, so I understand why they are so high on people's wish list. But we don't have them in PHP. In fact, I already told you why we cannot have generics. That is that PHP checks types at runtime. It does everything at runtime. It's an interpreted language. There's no compiler that can do type checks while compiling. It all needs to happen in real time. The static analyzers, they run apart from PHP itself because it takes some time to scan and understand your code base. PHP Stan and Psalm, they scan your code on the fly, and PHP Storm has the infamous indexing when booting the project. All of this time goes to understanding your code base, and you couldn't do that in real time. Now, to be clear, this is PHP's number one strength, the fact that you can make changes, refresh the page, and it just works without waiting for a compiler. But it's also PHP's weakness, because it prevents us from having things that are trivial in other languages, like generics. So, to clarify why they are so difficult to add in PHP, let's take a closer look at how generics could be implemented, because there are three possible ways. The first one is called monomorphic generics. It's a difficult word, but it essentially means that PHP would do the copy-paste work for us behind the scenes. It takes something that has multiple forms, like polymorph, and creates individual implementations for them, monomorph. So a generic collection class could be split into individual implementations, one for post, one for comments, one for likes, and so on. And it's PHP generating these classes for us based on our generic template. But doing so, requires resources, CPU time, and memory. In fact, it would require so many resources that our programs would become noticeably slower. That's not good. The next solution is called reified generics. And they seem like a pretty good fit for PHP because essentially these are runtime generics. They are generics that are checked on the fly at runtime, whose type information is available via reflection, which is basically how PHP's type system works today. Now, the main problem with reified generics is that they require a pretty big refactor to PHP's core. And on top of that, they would introduce lots of complexity all throughout that same code base. When Nikita was still working on PHP, he did look into this possibility. It's possible in theory, but Nikita and others felt that the end doesn't justify the means. Complexity is a pretty big thing. And to be clear, the complexities lie in the details, stuff like handling references and type inference. Yeah, those are pretty complex. And so we're stuck. Generics aren't coming to PHP. They would have too big an impact on either PHP's performance or maintenance, and it's just not worth it. But I told you there were three options, right? Yeah, the last one is perfectly doable. It doesn't have much, if any, runtime performance impact, and is pretty trivial to implement. The only thing needed is a mind shift, which might actually be the most difficult problem to overcome. It's called type erasure. And it basically means that PHP would get generic syntax, and that's it. It wouldn't do any checks at runtime. Now, how does that make sense? Why would you add generics and then not use them? Well, remember when I explained type systems and how PHP is kind of weird doing its type checks at runtime. I already showed you how static analyzers don't need to run your code to detect problems as long as we provide enough types. They can detect a range of bugs for us, and if we don't have to run our code to run type checks, then we don't have to worry about runtime performance issues. Now, this is that mind switch. We might not need runtime types. Static analyzers provide an even better level of safety without all the runtime problems. And this is what Nikita said when I asked him about runtime type checks versus static analyzers. Now, there's a problem though. Two, actually. First, not everyone wants to use static analyzers. Second, PHP uses runtime type information for things besides type checking. There's type juggling in PHP, and frameworks use type information for auto-wiring dependencies, just to name two examples. But these problems can be overcome. First, it's safe to assume that people who want to use generics are in that strictly typed, statically checked camp. They want generics mainly because of the value they offer statically and not at runtime. Second, PHP could still expose generics via reflection, and might even be able to use it for type juggling if needed. Remember that the main problem was with type checking and type inference, and those problems would be moved to the static side. Now, type erasure isn't anything new. Python, for example, does it. All its types are treated as comments during runtime. And Python trusts their users who want type safety to use a static analysis. And that makes sense because that's where the majority of value comes from when you're using types. Now, as you might be able to guess, I'm in that strictly typed, statically checked camp. I would love to have statically checked generics because they would save me just so much time and they would make my programming life much easier. So from my point of view, type erasure or runtime ignored generics would be the dream solution for PHP. They would have no runtime performance impact. It would be pretty trivial to implement because the difficult parts are outsourced to static analysis, and we'd still get all the benefits that runtime generics would offer thanks to static analysis. But the main problem is this is so different from what the PHP community is used to. Python's approach, it works because people have never known it to be any different. It also erases all its types and not just generics. PHP, on the other hand, already checks types at runtime, so it would be pretty weird if we'd add generics and have them be the only part of PHP's type system that isn't checked at runtime. So that's what I mean when I say a mind shift is required. This simple solution to generics raises a lot of questions about PHP as a programming language. Yeah, maybe it will evolve towards not checking types at runtime anymore. Maybe one day PHP will have an official opt-in static analyzer. Rasmus talked about this at one point, but it's a pretty big thing to get right. Maybe there can be multiple editions of PHP, one with generics and a required static type checking step, and one without generics, but with its existing runtime type checks. Now, Nikita did hint at the concept of PHP editions in the past, but Nikita has moved on from PHP. And on top of that, complexity is a pretty big thing, remember? So as you can see, lots of questions, which makes type erasure, unfortunately, unlikely to happen. And now I can truly say we're stuck. Generics are not coming. But if you're using static analysis in PHP today, you're probably thinking at this point, all of this is possible. Remember how Python treats type annotations as comments? Well, what's stopping us from doing so as well? Nothing. Statically checked generics are available in PHP, be it within doc comments and also without an official specification. Its syntax is a bit more verbose, especially with those additional template annotations. And there are some subtle differences between static analyses. But runtime ignored generics exist and work pretty much as I described. No runtime checks, no everything checked by static analyses like PHP Stan or SOM. And on top of that, PHP Storm does its best to support as many generic doc comments as possible in real time, following the syntax that PHP Stan and SOM propose. But of course, there are subtle differences. But most of the benefits of generics, combined with static type checking in your IDE and with static analysis, well, that is available in PHP these days. Of course, there are some downsides. I already said that there isn't an official spec, leading to small differences between implementations. And it also makes it so that PHP Storm is often slower to implement new generic features, trying to follow what static analyzers are doing. Also, these are comments, so they are more ugly and more verbose than when you'd have native syntax. And they are also inconsistent with PHP's existing type system because you need to mix built-in types with doc comments. But they do work. They solve 90% of use cases when you need generics. They aren't perfect, but honestly, no one expects PHP to be perfect, right? So where does all of this leave us? Now, personally, I would want a proper spec for generics, even if it's just a document that third-party static analyzers and IDEs should adhere to. It would be nice if this spec is endorsed by all static analyzers and IDEs, as well as PHP internals. The second thing I would want is native syntax instead of doc comments. I really dislike having to write part of my type definitions in PHP and another part in comments. It also wouldn't be the first feature to promote from comments to native syntax, just to say there is some precedence here. Let me name two pretty significant changes. At one point, all types in PHP were written in doc comments, and we moved away from those because native syntax is, quite honestly, much more convenient. Also, PHP 8 added attributes as a way to solve the whole annotation problem, and I don't think many of us regret that evolution. Now, next on my wish list, I really like Rasmus's idea of having an opt-in first-party static analyzer for PHP. I doubt it will ever come, especially since third-party tools like PHP Stan, they are really good. But still, in a perfect world, and if we could do it all over again, right? Finally, I wouldn't mind PHP not doing runtime type checks. It's okay to have type information available at runtime for performance reasons and also to do meta programming with reflection. So I'm not saying I would ditch PHP's type system entirely, but type checks, I will let PHP Storm and PHP Stan handle those for me. They are much better at it anyway. So yeah, generics in PHP. We started with a pretty clear feature request, and we ended with questioning the very nature of PHP. I think it's a good thought experiment, and I think we need to keep questioning where PHP is going. The best thing that we as userland developers can do is to support internals. So definitely check out the PHP Foundation and what they are doing. And I would say it's also worth checking out PHP Stan and Psalm and learn how you can contribute or support them. I do wonder how we'll look back on this whole generics debate 10 years from now. So if you're watching this talk in 2033, then you're free to remind me we're 10 years later. Share your thoughts with me. I would love to learn how all of you think about PHP's future. So thanks for being here. Thanks for making PHP awesome. And until next time.